Welcome to this class. Today I am going to start a new chapter, electricity, one of the very important chapter of subject science and technology of class 9, and this is taken in unit number 11. We have divided this chapter into 6 different parts, and today is the starting part, I mean to say part 1. And today I am going to tell you about electricity, what exactly it is. We are very used to with electricity. In a household circuit, we have seen so many things. Whenever we switch on the circuit, a bulb glows. When we switch on the circuit, then a heater gives heat energy. When we switch on the circuit, we get heat in the rice cooker and rice can be cooked. In this way, in a house only, there are many things which works with the electricity. Not only this, it is used widely in different sectors, in vehicles also, motorbike, in bus, in truck, in aeroplane, in railway also. Everywhere electricity is widely used. It is used in the computer also. That's why we have to know that exactly what happens and what flows in the conductor, and we say it electricity. That's why I want to focus on what electricity is. Now, one thing we have to be very clear, electricity is related to charged particle. Charged particle means there are two charged particles. One is electron, which are negatively charged particles. Another is proton, that is positively charged particle. And these two particles are actually concerned with the electricity. That's why, and they are present in atoms also. And actually the electrons and protons are associated with the atom. That's why without the understanding of the structure of atom, we cannot understand electricity. So I want to start with atom. All of we know that atom contains 3 different types of particles. They are electrons, protons and neutrons. And among these 3, the atom contains protons and neutrons in its nucleus. Nucleus contains protons and neutrons. They are packed with each other in the central part of the atom, which is called nucleus. And proton is normally symbolized by P+. The plus symbol represents that it is positively charged particle. And neutron is symbolized by generally N0. 0 represents that it is chargeless particle. It is not concerned with actually electricity. And there is another particle also which revolves around the nucleus through certain path, and this path is called orbit or cell, and these particles are electrons. And these electrons have negative charge and they revolve around the nucleus like this. This is the structure of atom. Now, what I want to say, 2 important points. Number 1, electric charge contained in 1 electron. Negative charge contained in 1 electron is equal to positive charge contained in 1 proton. And normally number of electrons and protons are equal in an atom, whether it is metal or non-metal, or it is iron, or it is copper or cobalt, everything. In any atom, the number of electrons and number of protons are equal. That's why amount of negative charge and amount of positive charge are also equal. And that's why they cancel each other. And an atom is usually neutral. This is one of the important points we have to remember. And there is no electricity in normal atoms. No electricity in any object if number of electrons and protons are equal. But by any process, look at the screen, but by any process, if an atom loses some electrons, in this case, let's say one of the electron is lost, then what happened? Now, number of electron is 2 and number of proton is 3. It means number of proton is more than number of electron. That's why the amount of positive charge is more than amount of negative charge. Because of this reason, now this atom becomes positively charged. Electricity is produced. The atom becomes positively charged. Not only one atom, the atoms of the object becomes positively charged and the whole object becomes positively charged. This way, the object becomes electrically charged, electricity is produced. But instead of this loss of electron, let's bring the electron back, look at the screen. And if an electron is gained by an atom, then what can happen? Now, number of electrons becomes more than the number of protons. Here, number of electrons are 4, but number of proton is 3. That's why number of electron is more. It means amount of negative charge is more than amount of positive charge. Now, the atom becomes negatively charged and the object also becomes negatively charged. This way, electricity produces in a body. And now, I want to tell you, this is of two types. Electricity is of two types. And what are they? One is called static electricity and another is called current electricity. And now I want to focus on static electricity first. Look at this. This is, let's say, woolen cloth, and this is a plastic rod. If plastic rod is rubbed on, if this plastic rod is rubbed on the surface of woolen cloth, then some of the electrons from the atoms of the woolen cloth transfer to plastic rod. And because of this transfer of electron, now the number of electrons in the atoms of plastic rod becomes more. And if electrons are more, then it becomes negatively charged. But on the other hand, in case of woolen cloth, electrons are transferred from woolen to this plastic rod. That's why number of protons are more now in the atoms of woolen cloth. So the woolen cloth becomes positively charged. This way, when one insulator substance, one insulator is rubbed on the surface of another insulator, sometimes what happens, electron may transfer from one object to the another object, and that produces the electric charge. Electricity is produced. And this production of electricity is because of this reason. I want to focus on 4 points. Number 1, this type of electricity, which is called static electricity, produces in insulator only. Look at these are insulator. Not only these, there are other materials also. Just for example, if glass rod is rubbed on the surface of silk cloth, then both of them electrifies. Okay, in insulator only, this type of electric charge produces. And number 2, this charge produces because of friction. Number 3, you have to remember, due to the distribution of charge. Distribution of charge. And number 4, you have to remember that it is static. I mean to say, this is static electricity, which you are taught a little in class 7 also. Actually, static electricity produces in insulator. Static electricity produces between two bodies due to the friction and distribution of charge. Look at this, charge is distributed, a little amount of electron is transferred to plastic rod, and this charge which is transferred, electron which transferred to plastic rod, where they gone, I mean to say, where the electron gone to plastic rod, it remains in the same atom. It won't flow from one atom to another atom, and it won't flow up to the another end of the atom. And this is called static because of this reason. This type of electricity never flows. It remains in the same place. Just for example, here some of the atoms are positively charged and they remain positively charged. Electron doesn't flow towards these positively charged atoms. Okay, we have to remember 2 important points also. Number 1, proton never transfer from one atom to another atom. Only electron can transfer from one atom to another atom. Reason is, number 1, electrons are very, very light particles. They are 1837 times lighter than that of the proton. That's why electron may transfer from one atom to another atom. But protons are very heavy. They are in the central part of the atom. That's why they never transfer. Second point, electrons lies in the peripheral part of the atom, that is outer part. That's why the chances of transfer of electron is maximum, but proton never transfer. That's why if a body becomes electrically charged, then the production of charge is because of the transfer of electron, nothing other than electron. Okay, now let's go back to static electricity and current electricity again. Static electricity can be defined with the help of these 4 points that I am going to present. Look at this. Electricity produced in the insulator due to the friction and distribution of charge which does not flow through the substance is called static electricity. This way we can define static electricity. Now it's time to go to current electricity. Before this, I want to tell you again the atomic structure. Look at this. Here the whole proton and neutron, this central part is represented by this nucleus. This nucleus means the whole proton and neutron contained in the central part is actually this labeled as nucleus. But in the nucleus we have proton which is symbolized by P plus and neutron which is symbolized by N0, but this nucleus, the arrow mark may be a little confusing, but this arrow mark says that the whole central part is nucleus. Okay, now I want to go to current electricity. Exactly what is current electricity? In this atom, if this lost electron goes to another atom and that repel the electron of another atom, and that also repel the electron of another atom, and electron moves from one atom to another atom and goes to another end, it means this is completely different case. The electron which are transferred to particular atom is not static, it is moving, and this moving electron actually produces current electricity. This is called current electricity because electrons are moving. This is not static. It can be represented this way also. Look at this. Let's say this is a conductor. I magnified this conductor and its thickness is shown very huge. And electrons are moving from one end to another end continuously. This is not static electricity. This is called current electricity. Now, how can we define current electricity? This way. Look at this. Electricity that flows through a substance or conductor is called current electricity. For example, electricity that flows in household circuit is current electricity. It means now you are clear that whenever we switch on the circuit, something flows in the conductor wire. And what flows? Electron flows. The continuous flow of electron is actually the current. And this is called current electricity. Now, do you know that all the electrons never flows in the substances? I mean to say, an atom may contain 50 electrons, 70 electrons, 20 electrons, but all the electron never flows from one end to the another end. They remain in their own place in the orbit and revolve around the nucleus. But few of them can move from one atom to another atom and can reach up to the another end, and this electron is called free electron. There are few free electrons. That's why I want to tell you about free electron. Free electron means that electron which is exactly not attached or associated with particular atom, but it moves throughout the body of that conductor or that substance. They are called free electron. We can define this way. Electrons which are not associated with the nucleus of atoms and free to move when external energy is applied are called free electrons. It means, now you have to understand this very clearly. Metals have huge number of free electrons. What it mean? It means some of the electrons in the atoms of the metal can move from one atom to another atom and can move from one end to the another end, but these free electrons are negligible in case of non-metals. Non-metals have very negligible number of free electrons. That's why flow of electron is possible only in metals. This is the key point. And free electrons flows, and we can say that this is the flow of current. Actually, free electrons are flowing through the conductor. Now, whether the electron or proton flows in the conductor, this is the question. Proton never flows. Electron flows, and the electrons have negative charge. Now we have to talk about the electric charge. What is the unit of electric charge? We can say SI unit of electric charge is Coulomb. Coulomb, in the name of the scientist, the unit of charge is taken as Coulomb, and it is symbolized by C. And what is 1 Coulomb charge? Electric charge contained in 6.24 into 10 to the power 18 electrons is called 1 Coulomb charge. This is a very big number. I want to say something about this. Look at this. What I told you just now, 6.24 into 10 to the power 18 electrons. This much electron contains 1 Coulomb negative charge, and the same number of proton contains 1 Coulomb positive charge. This number is very big. If 6.24 is multiplied by 10 to the power 18 means 1 having 18 zeros. Look at this, very huge number. If multiplied 6.24, then very huge number of electron comes. That much electron contains 1 Coulomb charge. We have to understand this way. We cannot express in words also, millions, billions, trillions. It is more than that. Okay, 1 proton, in the meantime, you have to remember that 1 proton or 1 electron contains 1.6 into 10 to the power 19 Coulomb charge. Now, let's understand about this also. 1.6 into 10 to the power minus 19 Coulomb charge can be written thirdly. See, how much is this charge? This is equal to 1.6 is if divided by 10 to the power 19. 10 to the power minus 19 is if taken to denominator, then we'll get positive 19, and this much number represents the electric charge contained in 1 electron. When 1.6 is divided by 1 having 19 zeros, then we'll get very small number, 0.0000000. After so many zero, then number comes. It's very less amount of charge is contained in 1 electron. This is just the understanding. We have to express very big number in terms of power of 10 and very small number also in terms of power of 10. Okay, now this is time to talk about the current, electric current. Now we are able to define electric current. What exactly it is? Let's talk about this. Electric current, the rate of flow of charge or the flow of charge in unit time is called current. Its SI unit is ampere, and it can be represented by the following formula: current I equal to charge Q by time T. Look at this. What it means? Rate of flow of charge mean how much charge is flowing in the conductor in 1 second time. That represents current. We can understand this way also. Look at this. This is a conductor. Let's say this is the thickness of the conductor represented by cross section area A. Now electrons are crossing this cross section, and electrons have negative charge. How much negative charge crosses this cross section in 1 second time? That represents the current flowing through this conductor. This way we can understand. Now here it is written its SI unit is ampere. Current is measured in ampere. Then what is 1 ampere current? We have to define 1 ampere current. When 1 Coulomb charge crosses a cross section of a conductor in 1 second, then the flow of current is called 1 ampere. Or we can define this way also. 1 Coulomb charge means 6.24 into 10 to the power 18 electrons. That's why when 6.24 into 10 to the power 18 electrons crosses a cross section of a conductor in 1 second, then the flow of current is called 1 ampere. This way we can define, and 1 ampere can be represented this way. 1 ampere equal to 1 Coulomb upon 1 second. Okay, till now what I told you, what is electricity? what is static electricity, what is current electricity, and in the meantime I told you about the electric charge also, atomic structure also, and then 1 coulomb charge also, and then what is current also. Now this is question time. Let's go to a question. Question is, which of the following relation is correct? Now I am going to show you relation. Number 1, 1 ampere equal to 1 coulomb into 1 second. Is this correct? Or 1 ampere equal to 1 second by 1 coulomb. This one is correct. Which one is correct? Just think about this. I'll tell you the correct answer. Number 3, 1 coulomb equal to 1 ampere by 1 second time, and 1 coulomb equal to 1 ampere into 1 second. Now we have to check each and every option and we have to declare which one is correct. I want to show you with the mathematical relation. We know that 1 ampere current is equal to 1 coulomb by 1 second, because current is equal to charge by time, and if current is taken 1 ampere, charge must be 1 coulomb and time is 1 second. That's why 1 ampere equal to 1 coulomb by 1 second is the correct relationship. The same is given here but in different ways. Look at this. 1 ampere equal to 1 coulomb into 1 second. This is incorrect because it should be 1 ampere equal to 1 coulomb upon 1 second. Yes, it is written here. This first option is incorrect. Now second option, 1 ampere equal to 1 second by 1 coulomb charge. Is this correct? No, this is just the reverse. It should be 1 coulomb by 1 second. That's why this is also incorrect. Now third, 1 coulomb equal to 1 ampere upon 1 second. If coulomb is taken in one of the side, then 1 coulomb is equal to 1 ampere multiplies 1 second. Is it like this? No. 1 coulomb equal to 1 ampere by 1 second. This is also not correct. Now last one, 1 coulomb equal to 1 ampere into 1 second. If this 1 coulomb is taken in the right hand side, 1 second is taken to left hand side, then 1 coulomb equal to 1 ampere into 1 second. Fourth one is correct option. That's why if we have to select one of the option among those 4, then we can select the last option, 1 coulomb equal to 1 ampere into 1 second. Okay, this is all about the current. We'll talk in detail in following classes also. But now it's time to talk about the device to measure the current. I mean to say, if something is flowing in this conductor, how can we say that something is flowing or not, or whether current is flowing or not? How much current is flowing through a conductor? How can we identify? We have to use a device which measures the flow of current in the circuit, and this device is called ammeter. Now I am going to show you a device, ammeter, which is used to measure what? Current. Look at this, we can define this way. Ammeter is an electrical device used to measure the flow of current in the circuit. You can be asked somewhere, what is ammeter? Your answer should be like this. Okay, I am going to show you ammeter. Look at this. This is ammeter. Now how it looks like? This one only ammeter. I have connected some other thing also here. This is ammeter. Now it looks like a box like electrical device, and it has 2 wire connecting points. Here wire is already connected, here also wire connecting point. One of them is symbolized here plus, another is symbolized here minus, and here we have ampere scale, and a scale is made on its surface. This is ampere scale, and there is a pointer here in this place. A pointer is present which moves and directly shows the value of current when connected in the circuit. When this ammeter is connected to a circuit, then it shows the current. How much is the current by the help of this pointer. But there is a little problem. What problem? I want to tell you about this. How can we use this ammeter to measure current flowing in the circuit? Use of ammeter, we have to remember that a cell having positive and negative terminal, when we connect it with bulb like this, then we can connect a switch also over there, and we have to connect emitter to measure the flow of current in this circuit. Then we will connect this way. The wire coming from positive terminal of cell or battery should be connected to plus symbolized wire connecting point of emitter, and wire coming from negative terminal of cell or battery should be connected to minus symbolized wire connecting point of emitter. And this way we can measure now current, how much current is flowing. We have to remember that emitter should be connected in series. What it mean? Emitter should be connected in series means the current which flows through this bulb all should flow through emitter also, and it is possible only when emitter is connected in series. This connection is series, and so what current is flowing through this bulb, the same is flowing through emitter also, and emitter shows the value of current. Okay, now I want to mention some points which we should take care while measuring current. Number one, emitter should be connected in series. How it is possible, I told you just now. And wire connected to positive terminal of cell or battery should be connected to the plus marked terminal of emitter, and the wire connected to the negative terminal of cell or battery should be connected to minus marked terminal of emitter. We will measure after this study, I mean to say after the method of connection. Current in the circuit should be previously estimated, and it should be less than the capacity of emitter, otherwise high current damages the emitter. Okay, now I want to revise this second point. Wire coming from positive terminal of cell or battery should be connected to plus marked terminal of emitter. If I am connecting these two cells here in the circuit, here we have emitter and switch is also already connected and bulb is also there, and if I am going to connect this, then this positive wire connecting point should be connected to this plus symbolized wire connecting point of this cell, and the wire coming from negative terminal of this emitter should be connected to this place. Otherwise what happens, instead of moving towards right hand side, the pointer moves in the opposite side towards the left hand side. If it moves towards left hand side, then mechanical damage may occur because there is no space to move towards left hand side, and the emitter may be damaged because of the opposite direction. Now point number 3, look at this. Current in the circuit should be previously estimated, and it should be less than the capacity of emitter. What it mean? If the current flowing in this circuit is 5 ampere, but the capacity of emitter is only 2 or 3 ampere, then what can happen? Then pointer of emitter moves faster and goes to right hand corner and collide at certain place, and mechanical damage may takes place. That's why the current in the circuit should be previously estimated. It should be less than the current really which flows through the circuit. Okay, now I am going to measure this. Look at this. If we connect this to negative terminal, and if this is connected to positive terminal, and if we switch on the circuit, look at this, bulb is now glowing and pointer of emitter is moved, and it is moved to 7 divisions. It is moved to 7 division. 20 division makes here, 20 division makes 1 ampere current. It means each of the division is equivalent with 0.05. 7 division means 0.35 ampere current is flowing at this time in this circuit. This way we can measure current flowing through a circuit. Okay, we finished this part also. What is emitter? How can we use emitter to measure the flow of current in the circuit? Now it's time to talk a little different. In every electric circuit, we are showing the direction of flow of current from positive terminal to negative terminal. But actually, what I told you in the explanation, electron flows, proton never flows. What it means? This is the controversy. In one side, I am saying that electron flows from negative terminal to the positive terminal, but in another side, I am showing the direction of flow of current from positive terminal of the cell or battery to the negative terminal. What is this? Actually, at the time of invention of these cells and batteries, scientists had no idea whether the electron flows in the circuit or proton flows in the circuit. Unknowingly, the direction of flow of current was given from positive terminal to negative terminal. Later, they came to know that this is completely different. It's wrong, just opposite. Electron flows from negative terminal to positive terminal. Now, many books were published, hundreds of or thousands of books were published, and that's why what they decided, let it be, let's say, this is traditional direction of flow of current and it is named as conventional current. And we have to understand that electron flows from negative terminal to positive terminal, but let's continue the direction of flow of current from positive to negative, and it is named as conventional current. Now, how can we define conventional current? This is the definition. The traditional direction of flow of current that flows from positive terminal to the negative terminal of cell or battery is called conventional current. Okay, we understood about the conventional current also. Now at last I want to solve a numerical problem related to current. Let's go through this also. If 2 ampere current flows in a conductor for 4 seconds, calculate the number of electron which crosses a cross section of that conductor. What the question? Look at this again. 2 ampere current is given, time is given 4 seconds, 2 ampere current is flowing till 4 seconds. Now, what is the number of electron that crosses any one of the cross section of that conductor? This is the question. We can solve it very easily. Look at this. First, we have to write the given. Current is given. Current I is given 2 ampere. And next, what is given? Time is given. Time t, this is 4 seconds. And what is the question? Number of electron. Number of electron can be represented by E minus is equal to question mark. Now we have one equation. I told you about this. Current is equal to charge by time. This is equal to, current is given 2 ampere and charge we have to find out, and then we'll be able to find out the number of electron. Time is equal to what? 4 seconds. Or this is equal to 2 ampere into 4 seconds is equal to Q. Therefore, Q charge equal to 8 coulomb charge. Now this is our solution, but till now how many electrons is not declared. That's why I can say this way: 1 coulomb charge contains 6.24 into 10 to the power 18 electrons. Then 8 coulomb charge contains 6.24 into 10 to the power 18 into 8 electrons. And if we multiply this, 8 multiplied by 4, 32, 2 is there, 3 is carry over, 8 2 is 16, plus 3, 19, 9 carry over 1, 8 6 is 48, 48 carry over 1, 49. Now after point there are 2 digits, that's why we have to put here into 10 to the power 18 electrons. But I think I told you many times in the chapter motion also, we have to put this decimal point after 1 digit. That's why I'm going to shift this here 4.992. If point is shifted left hand side, 1 digit left hand side, then we have to multiply it with 10 or 10 to the power 1, then this number is equal to this number, and 10 to the power 18 is already there, and this is equal to 4.992 into 10 to the power 1 plus 18 equal to 10 to the power 19. Same base, that's why power can be added. This is the final answer. Now, what number of electron flows through the conductor? 4.992 into 10 to the power 19 electrons flows through the conductor. This way we can solve numerical problem also. The major point is you have to remember that current is equal to charge by time. Okay, today we focused on different matter. Now I think you are able to define static electricity, current electricity, and you are able to define what is current also, and you are able to define the 1 coulomb charge also, and I expect that you will be able to solve the numerical problem, simple numerical problem related to current. Okay, we'll meet with more information in next class. Today our time is finished. Thank you.